Number 1. The Octopus from Space Hypothesis. In March of 2018, a paper appeared in a journal called Progress in Biophysics and Molecular Biology. It carried 33 authors from 8 countries. The lead author was Edward Steele, an Australian immunologist. The journal was edited at the time by Dennis Noble, a physiologist at Oxford with a serious reputation. This was not a vanity outlet. The paper argued that the octopus did not evolve on Earth. The specific claim was this: frozen cephalopod eggs arrived inside an icy bolide roughly 275 million years ago. They survived the fall. They seeded the oceans. Everything we recognize as an octopus descends from that delivery. The motivation was real. In August of 2015, a team led by Caroline Albertine published the first full octopus genome in Nature. They sequenced Octopus bimaculoides, the California two-spot octopus. It carried roughly 33,000 protein-coding genes. The human genome carries roughly 20,000. That was not the strange part. The strange part was the architecture. The octopus genome contains 168 protocadaran genes, a family involved in wiring nervous systems. Most invertebrates carry 1/10 of that. The genome also showed almost no preserved long-range synteny, meaning the gene order had been comprehensively scrambled relative to its relatives. Then came the editing. In 2017, a team documented more than 60,000 sites in squid where the animal rewrites its own messenger RNA before translating it. Humans do this at a handful of sites. Steele looked at that and saw novelty with no ancestor. The mainstream looked at the same data and saw gene duplication followed by neofunctionalization, which is a well-documented process that happens everywhere in biology. The intellectual lineage runs back to Fred Hoyle and Chandra Wickramasinghe, who argued in the 1970s that life arrived from space. Wickramasinghe co-signed the octopus paper. The evidence offered was survivability. Tardigrades survived raw vacuum and solar ultraviolet on the Photon M3 mission in 2007. Here's what the paper never addresses. An octopus egg is a soft, water-rich cell. Atmospheric entry would destroy it, and millions of years of cosmic ray exposure in transit would shred its DNA. Neither problem is modeled anywhere. Karin Mulling of the Max Planck Institute for Molecular Genetics published a formal rebuttal in the same journal. Her objection was not that the idea was offensive, it was that the idea generates no testable prediction, so it cannot be examined at all. The fossil record disagrees separately. Cephalopods appear roughly 530 million years ago. Molecular clocks place the octopus and squid split near 135 million years ago. Neither number fits the proposed arrival date. The paper has never been retracted. It sits in the literature, accumulating citations, most of them hostile, which tells you something uncomfortable about how this system works. Peer review filters for competence, not for correctness. And the reaction to the people who did publish is exactly why so many others never do. Number 2, the Triassic Kraken Lair Hypothesis. Before the outrageous part, there is a real problem. In the desert of Nye County, Nevada, there is a bone bed inside the Looning Formation. It is roughly 217 million years old from the Norian stage of the late Triassic. It contains at least 37 individual marine reptiles of the species Shonosaurus popularis. 9 of them lie together in a single dense cluster. Shonosaurus reached roughly 15 meters in length. Nevada named it the state fossil in 1977. The site was first noted by Simon Muller in 1928. Charles Camp of the University of California, Burckle, excavated it between 1954 and 1965. Camp read the assemblage as a mass stranding, a Triassic version of a modern whale beaching. That explanation held until 1992 when Jennifer Hogler re-examined the sediment and the associated fauna. Her conclusion was that these animals died in water at least 100 meters deep. Nothing strands in 100 meters of water. The stranding explanation collapsed and it left a genuine open question. How do 9 enormous predators end up dead in one spot on a deep seafloor? In October of 2011, Mark McMenamin, a professor of geology at Mount Holyoke College, presented an answer at the Geological Society of America annual meeting in Minneapolis. He had noticed that some of the vertebral discs at the site lay in linear, double-row arrangements. They did not look randomly scattered to him. They looked placed. His proposal was a cephalopod roughly 30 meters long. It drowned the ichthyosaurs, dragged the bodies to a lair, and arranged the vertebrae in a pattern that mimicked its own sucker discs. He called it a self-portrait. There is behavioral precedent, and it is genuinely interesting. Octopus vulgaris builds middens, stacking crab carapaces and shells in deliberate arrangements outside its den. The scale is. The largest confirmed giant squid, Architeuthis dux, reaches roughly 13 meters, including its feeding tentacles. The colossal squid is heavier but shorter. Nothing in the fossil or living record approaches 30 meters, and no such animal has ever been found. McMenamin's defense was that coleoid soft tissue almost never fossilizes, so its absence is exactly what you would expect. That is the sentence that ended the discussion. When a theory absorbs the absence of its own evidence as confirmation, it stops being testable. It becomes a story that cannot lose. The ordinary explanation is duller and stronger. Vertebral discs are flat, dense, and roughly cylindrical. Bottom currents sort objects like that into lines. Decay releases them in sequence along the spine, which produces order without intention. The response was immediate ridicule, and the cost of that is not McMenamin's reputation. The cost is that 9 ichthyosaurs are still lying there, still unexplained, and the field learned that proposing anything unusual about that site is professionally expensive. Number 3, the Silurian Hypothesis. In April of 2018, 2 working scientists published a question in the International Journal of Astrobiology. Gavin Schmidt directs the NASA Goddard Institute for Space Studies in New York. Adam Frank is a professor of astrophysics at the University of Rochester. The question was this: if an industrial civilization had existed on Earth before us, would we be able to detect it in the geological record? They named it the Silurian Hypothesis after a 1970 Doctor Who serial featuring an intelligent reptilian species that predated humanity. The joke was deliberate, and it was a mistake, because the name is what people remember and the argument is what matters. Both authors state repeatedly and explicitly that they are not claiming a previous civilization existed. It is a sensitivity test on our own instruments, and the answer it reaches is deeply uncomfortable. Start with the land. Almost no exposed land surface older than a few million years survives. The continents are constantly being resurfaced, so the long archive is not on land. It is ocean sediment laid down in quiet layers on the seafloor. Except that archive is temporary too. Oceanic crust is destroyed. It is manufactured at mid-ocean ridges and consumed at subduction trenches. The oldest seafloor anywhere on Earth is roughly 180 million years old in the western Pacific near the Mariana Trench. A contested older patch in the Herodotus Basin of the eastern Mediterranean may reach 340 million years, and that is the absolute outer limit. Anything that happened in the oceans before the Jurassic has had its sediment record fed into the mantle. Not lost. Destroyed by the planet on a conveyor belt. Now consider scale. The human industrial era is roughly 300 years old. Deep-sea sediment accumulates at a few centimeters per 1,000 years. 3 centuries of global industry is a lamina thinner than a fingernail. Schmidt and Frank argue that rate matters more than magnitude. A short, violent carbon spike is the signature, not a long warm period. Their closest natural analog is the Paleocene-Eocene thermal maximum, 55.5 million years ago. That event shows a carbon isotope excursion of 3 to 7 parts per thousand and warming of 4 to 7 degrees Celsius. But the carbon went in over 4,000 to 20,000 years. Ours is going in over 200. That difference in rate is the diagnostic, and it is the only diagnostic they can rely on. The best deep-sea record of that event comes from Ocean Drilling Program Site 1262 on Walvis Ridge in the South Atlantic. The markers you would look for are fly ash spherules, industrial nitrates, synthetic organic residues, and transuranic elements. Plutonium-239 has a half-life of 24,100 years, so even our nuclear signature fades within a few 100,000. The conclusion is not that something is buried down there. It is that if something were, we would almost certainly never know. Number 4. The Burckle Crater Deluge Impact. In 2006, a group of researchers assembled under the name the Holocene Impact Working Group Dallas Abbott is a marine geologist at the Lamont Doherty Earth Observatory of Columbia University. Bruce Massey was an archaeologist at Los Alamos National Laboratory. They propose that a crater sits on the floor of the southern Indian Ocean, roughly 30 kilometers across, near 30.9 degrees south and 1.4 degrees east. It lies under roughly 3,800 meters of water, about 1,500 kilometers southeast of Madagascar. They named it for Lloyd Burckle, a Columbia paleoceanographer. The date they proposed was roughly 2,800 years before Christ. Masso argued for 2,807 specifically. That precision is where the trouble starts, because of how he derived it. Masso compiled roughly 175 flood myths from cultures across the world. He was looking for shared physical detail, the kind of thing a witness reports rather than a storyteller invents. The motifs he found recurring were darkness at midday, a hot wind, an enormous wave, and torrential rain afterwards. That is, in order, the sequence an ocean impact would produce. On the ground, there are physical features. The southern coast of Madagascar carries chevron-shaped sediment formations known as the Funambusy chevrons. Some reach 200 meters in height, some extend 45 kilometers inland. The group read them as deposits from a wave of impossible size. They also reported deep-sea sediment containing fused microspherules, nickel-rich grains, and impact glass. Then the rebuttal arrived. In 2009, Joanne Bourgeois and Robert Weiss published a paper in Geology with a title that left no room for negotiation. Chevrons are not mega-tsunami deposits. Their argument was that the forms are parabolic dunes, built by prevailing wind. James Goff and colleagues extended that critique across the group's other claimed sites. What is missing matters more. There is no independently replicated iridium anomaly. There is no confirmed shocked quartz. There is no seismic imaging of the seafloor structure at anything like the resolution needed to establish an impact origin. Burckle crater is not listed in the Earth Impact Database, which recognizes roughly 190 confirmed structures worldwide. And yet the idea will not resolve because of one precedent. Roughly 2.5 million years ago, an asteroid struck the Bellingshausen Sea in an event called the El-Tenian impact. It is confirmed, and it left no crater at all, only disturbed sediment layers. So deep ocean impacts can be nearly invisible. That single fact makes Burckle plausible and simultaneously unprovable. And because mixing flood mythology into impact geology guaranteed a fringe label, almost nobody has gone back to core the site properly. Number 5. Earth's hidden ocean, inside the mantle. This one begins with an ugly diamond. It came from an alluvial deposit near Juína in Mato Grosso, Brazil. It measured roughly 3 millimeters, was commercially worthless, and was flawed, which is precisely why it mattered. Inside it sat an inclusion about 40 micrometers across. On the 13th of March 2014, a team led by Graham Pearson published the analysis in Nature. The inclusion was ringwoodite. It was the first sample of terrestrial ringwoodite ever recovered from the Earth's interior. Ringwoodite is a high-pressure form of olivine, magnesium iron silicate. It is stable between roughly 525 and 660 kilometers down. It is named for Ted Ringwood of the Australian National University, and it was first identified in 1969 in the Tenem meteorite. The measurement that changed things was the water content. The inclusion held approximately 1.4% water by weight, bound as hydroxyl inside the crystal lattice. Now scale that up. The mantle transition zone spans roughly 410 to 660 kilometers depth. If a water content near 1% is typical across that entire volume, the bound water would total between 1 and 3 times every surface ocean combined. Earth's oceans hold roughly 1.335 billion cubic kilometers. Here is the correction: almost every headline destroyed. This is not liquid water. There is no cavern down there. It is hydrogen chemically bonded into rock, and it would not flow if you opened a hole to it. The accurate version is stranger than the myth, because it means the planet's largest water reservoir is not wet. Independent support arrived within months. In June of 2014, Brandon Schmant and Stephen Jacobson used data from the US A-Ray seismometer network to detect partial melt just below the 660-kilometer discontinuity beneath North America. That melt is exactly what hydrated rock should produce as it rises out of the depth range where it can hold water. Two different methods, one answer. The mineralogy explains why the water is trapped. Wadsleyite, the phase between 410 and 525 kilometers, can hold up to 3.3% water in laboratory tests. Bridgmanite, which dominates the lower mantle below 660, holds almost none. So that boundary acts as a filter, catching water on its way down. Above it, a deep water cycle operates continuously. Subducting slabs carry hydrated minerals downward at roughly a gigaton per year. Arc volcanoes return part of it to the surface. In March of 2018, the same Juina diamond family produced natural ice 7 inclusions, reported by Oliver Chauner and colleagues, direct evidence of aqueous fluid at extreme depth. The caution's real. Super deep diamonds are a biased sample, and extrapolating global chemistry from micrometer inclusions is an enormous reach. But the implication is worth sitting with. The ocean may not have fallen from the sky. It may have come up from underneath. Number 6. The expanding Earth hypothesis. There is a version of Earth's history in which the continents never moved at all. They simply spread apart because the planet underneath them was inflating like a balloon. It is wrong, and far harder to refute from ocean data alone than you would expect. Ott Christoph Hilgenberg published Vom Wachsenden Erdball, meaning On the Growing Earth, in 1933. Its most credentialed defender was Samuel Warren Carey, professor of geology at the University of Tasmania, who argued for it from the 1950s until his death, and published a book on it in 1976. Carey did foundational work on oroclines, the bending of mountain belts that is still cited today. Bruce Heezen, who co-mapped the mid-ocean ridge, was briefly sympathetic. If you take the continental shelves rather than the coastlines and fit them together, they join more neatly on a sphere with a smaller radius than the one we have. Then, in 1963, Fred Vine, Drummond Matthews, and Lawrence Morley showed that the seafloor carries symmetrical magnetic reversal stripes on both sides of mid-ocean ridges. New crust is manufactured continuously. That is the ocean floor, telling you unambiguously that it is growing. Add the ages. No oceanic crust anywhere on Earth exceeds roughly 180 million years. Continental cratines reach nearly 4 billion. That is a 20-fold difference across a single planet, and about 70% of the surface is the young half. The expansionists said the sphere grew and the ocean basins are stretch marks. Plate tectonics said something else and had to prove it. Crust is destroyed at trenches exactly as fast as it is made at ridges. The proof came in two forms. First, the Wadati-Benioff zones, plains of earthquakes that dip from ocean trenches down to roughly 700 kilometers. Q. Wadati mapped them from 1928, Hugo Benioff from 1949. Those plains are slabs of ocean floor descending into the mantle, lit up by their own failure. Second, ophiolites, slabs of ocean crust thrust up onto continents. The final measurement came from outside geology entirely. In 2011, Xiuping Wu and colleagues at the NASA Jet Propulsion Laboratory combined satellite laser ranging, very long baseline interferometry, global positioning data, and the DORA system. Their result was a mean radius change of 0.1 plus or minus 0.2 millimeters per year. That is statistically indistinguishable from zero. Expansion also required either creating mass from nothing or collapsing the planet's density, and the measured moment of inertia allows neither. The theory is dead. It earned its place here anyway because it forced geology to demonstrate that crust is destroyed rather than simply assume it. Subduction became a measurement instead of an assumption, and that happened because somebody refused to agree. Number 7. The Zanclean Megaflood. Roughly 6 million years ago, the Mediterranean Sea dried up. Almost completely. It became a hypersaline desert sitting up to 2.5 kilometers below the level of the world ocean, and it stayed that way for hundreds of thousands of years. The event is called the Messinian Salinity Crisis, running from 5.97 to 5.33 million years ago at the end of the Miocene. It was discovered in 1970 on Leg 13 of the deep-sea drilling project aboard the ship Glomar Challenger, with Kenneth Xu and William Ryan as co-chief scientists. What came up in the core barrels should not have been there. Gypsum, anhydrite, halite. These are evaporate minerals, and they only form when a body of water dries out. They were sitting beneath the Mediterranean abyssal plain. So were stromatolites and desiccation cracks recovered from under what is now nearly 3 kilometers of water. The total evaporate volume is estimated near 1 million cubic kilometers. That is roughly 6% of all the salt dissolved in the entire world ocean sitting in one basin. Then the Atlantic came back. The refill is dated to 5.33 million years ago, and it defines the boundary between the Miocene and the Pliocene. The evidence for how it happened was published in Nature in December of 2009 by Daniel Garcia Castellanos and colleagues using borehole and seismic reflection data from the Gibraltar Arc. They found a buried erosion channel. It runs roughly 200 kilometers long and between 6 and 11 kilometers wide. It is incised up to 500 meters into bedrock, and it was cut by water. Estimated peak discharge through that channel is on the order of 100 million cubic meters per second. The Amazon averages about 209,000. So this is roughly 1,000 Amazons through a single gap. Flow velocity is estimated near 40 meters per second, which is 144 kilometers per hour. Inside the basin, sea level rose as fast as 10 meters per day at peak. 90% of the Mediterranean refilled in somewhere between a few months and 2 years. In 2018, Aron Mikolev and colleagues identified a second stage where rising water overtopped a sill near Sicily into the Ionian Basin. Not everyone accepts the speed. Marco Roveri and colleagues argue for a more gradual reconnection and dispute the deep desiccation model entirely, favoring evaporate deposition in shallow water. The sediment can be read both ways. The consequences are visible elsewhere. The deep Mediterranean fauna was effectively erased and had to be recolonized from the Atlantic, which is why the basin shows strikingly low deep water endemism today. And with base level 2 kilometers lower, the Nile cut a canyon 2,500 meters deep at Aswan, found only by drilling. Number 8, the Younger Dryas Impact Hypothesis. This is the theory that will not die, and the reason is structural rather than evidential. Roughly 12,900 years ago, the planet was warming out of the last glacial period, then it reversed. Temperatures in the North Atlantic region dropped back toward glacial conditions and stayed there for about 1,200 years. The period is called the Younger Dryas, named for an Arctic flower whose pollen marks it in European sediment. The end of it was violent. Greenland ice cores from the GISP 2 and NJP projects show the termination happening in under a decade, with warming near 10 degrees Celsius. In October of 2007, Richard Firestone, Alan West, James Kennett, and colleagues published a proposal in the Proceedings of the National Academy of Sciences. A fragmented comet, they argued, airburst over or struck the Laurentide ice sheet in the North Atlantic. Their evidence was a dark sediment layer known as the black mat, and what they said it contained. Magnetic microspherules, carbon spherules, nanodiamonds, including the hexagonal form lonsdaleite, iridium. Later in 2013, Michael Pitev and colleagues reported a platinum anomaly in the GISP-2 Greenland core. They claimed the layer at sites across continents: Murray Springs in Arizona, Halls Cave in Texas, Lake Quetzeo in Mexico, Abu Hurira in Syria. The consequences they proposed were enormous. The collapse of Clovis material culture, the extinction of roughly 35 genera of North American megafauna. The ocean is where the mechanism lives. An impact on an ice sheet releases meltwater. Meltwater floods the North Atlantic. Freshwater caps the surface, stops deep water forming, and shuts down the circulation that carries heat north. That part is not disputed. In 2004, Jerry McManus and colleagues published protactinium to thorium ratios from Bermuda rise sediment in Nature, showing a sharp reduction in circulation right at the Younger Dryas onset. The mainstream candidate is a glacial Lake Agassiz outburst, routed either down the Mackenzie or the St. Lawrence, with a Fennoscandian route proposed by Francesco Muschitiello in 2015. No comment required. Then the rebuttals arrived. In 2009, Todd Saravel and colleagues failed to reproduce the magnetic spherular concentrations at 7 sites using the original protocol. In 2011, Nicholas Pinter and colleagues published a paper titled, Without Subtlety, a Requiem for the Hypothesis. Tyrone Dalton and colleagues argued the nanodiamonds were misidentified graphene and graphane aggregates. Vance Holliday attacked the chronology in 2014 and again in 2023, arguing the markers are not synchronous between sites. Then, in November of 2018, Kurt Kerr and colleagues announced a crater 31 kilometers across buried under the Greenland ice sheet called Hiawatha. It was seized on immediately as the missing impact site. In 2022, Gavin Kenny and colleagues dated it to roughly 58 million years ago, and here is the structural problem. An ocean or ice sheet impact leaves no crater, so the theory survives the loss of every candidate forever. Number 9. The Aquatic Ape Hypothesis. The most revealing fact about this idea is not the idea. It is that the man who developed it sat on it for 3 decades because he was afraid of what it would do to his career. Alistair Hardy was a professor of zoology at Oxford and a marine biologist by training. He conceived the hypothesis in 1930. He said nothing publicly until 1960, when he finally described it in a New Scientist article titled, "Was Man More Aquatic in the Past?" 30 years of silence by his own admission because of the professional risk. The idea passed to Elaine Morgan, a Welsh television screenwriter with no formal training in anthropology. She published The Descent of Woman in 1972 and The Aquatic Ape in 1982. The proposal is that at some point in our ancestry, a population spent significant time in water, and that this shaped the body you are currently sitting in. The evidence offered is a list of oddities. Humans carry a subcutaneous fat layer bonded to the skin, which is standard in marine mammals and unusual among primates. We are relatively hairless, and Hardy argued the remaining hair tracts are oriented along the lines water would flow over a swimming body. We have a descended larynx and voluntary breath control, both rare on land and standard among diving animals. We also have the mammalian dive reflex. Put your face in cold water and your heart rate drops and your peripheral blood vessels constrict. Newborns arrive coated in vernix caseosa, a waxy layer otherwise documented mainly in seals. And our primary cooling system dumps salt through the skin, which is an expensive strategy on an arid savanna and a cheap one beside water. The definitive rebuttal came from John Langdon in the Journal of Human Evolution in 1997. His objection is methodological rather than factual. Each trait has a better supported individual explanation. Bundling them under one cause creates what he called an umbrella hypothesis, which explains everything and therefore predicts nothing. In 2013, Alice Roberts and Mark Maslin wrote a Guardian piece with the headline, "Sorry, David Attenborough, we did not evolve from aquatic apes," after Attenborough revived the subject on BBC Radio 4. And while the strong version was being buried, the moderate version quietly won. Coastal and lakeside resource use is now mainstream in human evolution. In 2015, Josephine Jordaens and colleagues published a deliberately engraved freshwater mussel shell from Trinil in Java, roughly 500,000 years old, associated with Homo erectus. In 2020, Paola Villa and colleagues described clamshell tools from Grotta dei Moscherini in Italy that Neanderthals collected from the seafloor. In 2019, Eric Trinkos reported that Neanderthal skulls show external auditory exostoses, the bony growths modern surfers develop from cold water immersion at unusually high frequency. Nobody calls that the aquatic ape hypothesis. But Hardy's 30 years of silence bought him nothing. Number 10. The cometary origin of Earth's oceans. You already know this one. Comets delivered Earth's water. It is in textbooks and in classrooms. It is also, at the moment, unsupported by the best measurements we have. Earth's surface water totals roughly 1.335 billion cubic kilometers. That is about 0.023% of the planet's mass. The ocean is a film. The reason it needs explaining at all is where Earth formed. The young planet sat inside the solar system's snow line. Inside that line, ice should have been driven off, so the water has to arrive from somewhere colder. The tool used to trace it is the ratio of deuterium to hydrogen. Deuterium is hydrogen with an extra neutron. That ratio depends on where the water formed, and it does not change much afterwards. It is a fingerprint. Earth's reference value taken from ocean water is 1.5576 times 10 to the minus 4. Roughly 156 deuterium atoms per million hydrogen atoms. The first comets measured came from the Oort cloud. Halley, Hyakutake, Hale-Bopp. They came in near 2 to 3 times 10 to the minus 4, roughly double Earth's value. That was the first serious blow. Then, in 2011, Paul Hartog and colleagues used the Herschel Space Observatory to measure Comet 103P, Hartley 2, a Jupiter family comet from a different reservoir. It came in at 1.61 times 10 to the minus 4, statistically indistinguishable from seawater. The theory was rescued. Jupiter family comets, the argument went, delivered the water. Oort cloud comets did not. 3 years later, that collapsed. In December of 2014, Catherine Altweg and colleagues published measurements from the Eurosina instrument aboard the Rosetta spacecraft orbiting Comet 67P, Churyumov-Gerasimenko. The result was 5.3 times 10 to the minus 4, roughly 3 times Earth's value and the highest ever measured in any comet. 67P is also a Jupiter family comet, so two members of the same population differ from each other by more than a factor of 3, and the rescue argument collapsed. Carbonaceous chondrite meteorites of the Ci and Cm classes measure between 1.4 and 1.6 times 10 to the minus 4, matching Earth well, and they can carry up to 10% water by weight. In 2017, Nicholas Dufour showed in Nature that Earth's chromium, titanium, and ruthenium isotopes match and statiate chondrites from the inner solar system. Nitrogen isotopes give a second independent tracer, and they also point away from comets. In 2021, Luke Daly and colleagues showed solar wind hydrogen implanted directly into the rims of dust grains returned from asteroid Itokawa. And there is the Mantle reservoir we discussed earlier, which would mean much of the water was never delivered at all. Sample return is now settling it. Ryugu came back in December of 2020 and Bennu in September of 2023, carrying hydrated clays and phosphates. But Rosetta found something that undermines the whole method. The ratio at 67P varied with the comet's activity and with where in the coma you measured, which raises the possibility that 50 years of argument rested on a fingerprint that smudges. Step back from the individual cases, and a machine becomes visible. Formal refereeing began at the Philosophical Transactions of the Royal Society in the 17th century, but systematic external review is much younger. Nature did not adopt it until 1973. What review tests is method and competence. It does not test truth. A well-executed wrong paper passes, and the Octopus paper is the proof. 33 authors, a real journal, a serious editor, and no retraction to this day. The system has known distortions. In 1979, Robert Rosenthal named the file drawer problem. Positive and novel results publish far more easily than null results, so the literature skews toward things that seem to work. Replication is rewarded far less than novelty. Suravel's failed reproduction of the younger Dryas spherules took 2 years to appear. Reviewers are anonymous, unpaid, and frequently competing for the same grants as the people they are judging. The fastest route to rejection is an unfalsifiable structure. That is what killed McMenamin's Kraken, and it is what Langdon used against the Aquatic Ape. Both were about the claim being unable to lose. Then there is the cost that never appears in any record. A wrong paper follows a name permanently. Grant cycles run 3 to 5 years, which punishes anyone proposing a long shot. Alistair Hardy's 30 years of silence is the only clean measurement of that cost we have, and it is only visible because he eventually spoke. Everyone who stayed quiet left nothing behind to count. The system optimizes for reliability, and reliability is purchased with false negatives. That is a trade, not a neutral filter. And when the subject is the ocean, every one of these costs gets worse. A research vessel costs on the order of tens of thousands of dollars per day to operate. Deep submergence assets are booked years in advance through competitive proposals, and only a handful of vehicles worldwide can reach full ocean depth at all. No review panel awards that time to a speculative idea, which means hypotheses like Burckle crater are not refuted, they are simply never tested. The site sits there, 3,800 meters down, uncored. Then there is coverage. Most of the global seafloor is mapped from satellite gravimetry, which infers the shape of the bottom from variations in sea surface height. That gives you roughly 5-kilometer resolution. Direct high-resolution sonar coverage only recently passed a quarter of the seabed. Put plainly, large areas of Mars are mapped in more detail than the floor of our own ocean. A 30-kilometer crater can hide in that gap without effort. The archive itself is limited. Oceanic crust older than 180 million years does not exist to be sampled anywhere. And within that window, Sediment cores are single narrow columns standing in for entire basins. Dating precision in marine sediment is often coarser than the events being argued about, which is exactly why the younger Dryas synchrony fight cannot be settled. Bioturbation makes it worse. Burrowing organisms mix the top layers continuously, smearing sharp signals across centuries. A 300-year industrial pulse is thinner than the mixing depth of many of those animals. Pressure at 4,000 meters is roughly 400 atmospheres. Equipment loss is routine, and losing a vehicle can end a research program. And some things cannot be sampled at any price. Nobody will ever drill to the Mantle transition zone. The only reason we have ringwoodite at all is that a diamond brought a fragment up by accident. The record is short. The coverage is thin. The access is expensive. That combination does not produce conspiracies, it produces silence. It would be easy to end there, and dishonest, because sometimes the ridiculed position is simply right. Alfred Wegener proposed continental drift in 1912 and was rejected for 5 decades. His weakness was not evidence. He had matching fossils, matching rock sequences, matching coastlines. His weakness was that he had no mechanism. He died on the Greenland ice sheet in 1930, decades before vindication. And when vindication came, it came from the ocean floor in the form of magnetic striping. The coelacanth was presumed extinct for roughly 66 million years. In December of 1938, one came up in a trawl net off East London, South Africa. Marjorie Courtenay Latimer recognized that it was extraordinary and fought to preserve it. J.L.B. Smith identified it formally. 66 million years of confident absence ended by one fishing boat. Hydrothermal vents were not predicted by anyone. In February of 1977, the submersible Alvin found them at the Galapagos Rift. The dive team carried no biologists because nobody expected life. They found dense communities running on chemical energy rather than sunlight. That single discovery reopened the question of where life on Earth began. But the counter cases deserve equal weight. N-rays, polywater, and cold fusion all had credentialed defenders and confident published results. All 3 evaporated under blind testing. So ridicule is not evidence of being right. The base rate strongly favors the skeptics. The asymmetry is what matters. The cost of accepting a false theory is visible, immediate, and paid by the person who accepted it. The cost of rejecting a true one is invisible, delayed, and paid by somebody else entirely. No institution is built to measure the second kind of error, so nobody does. So rank them. Not by how strange they sound, but by how close each one sits to a measurement that could settle it. The Mantle water reservoir is barely contested at this point. It is effectively accepted, and its remaining problem is sample size rather than plausibility. The Zanclean Megaflood is second. Only the speed is contested, and new seismic surveys around Sicily are actively narrowing the estimate. Third is the moderate waterside model of human evolution, which has already won without being credited. Neanderthal ear exostoses and seafloor collected clam tools are physical evidence. Fourth is the origin of Earth's water, where the consensus is unstable and where samples from Rugu and Bennu will force a resolution. Fifth is the Silurian Hypothesis, which is not a claim and therefore cannot be refuted. Its value is as a standard, a rigorous statement of what deep-sea sediment can and cannot record. Sixth is the younger Dryas impact. It needs one clean stratigraphic result from an independent group. It has failed that test repeatedly, and each revival has been narrower than the last. Seventh is Burckle crater, which needs seafloor imaging that nobody is funding. Eighth is the Triassic Kraken, which needs a body fossil that will almost certainly never exist. Ninth and 10th are the expanding Earth and the Octopus from space, both closed by direct measurement. That ranking does not track plausibility, it tracks testability. Every idea that specifies a measurement is either accepted or on its way. Every idea that explains away the absence of its own evidence is stuck permanently. That is the actual dividing line this whole list has been circling, and it is why the strangest sounding item here, an ocean of water locked inside rock 600 kilometers beneath your feet, is the one closest to being simply true. Every theory in this video succeeded or failed on the same thing, not on politics, on what the seafloor happened to preserve. The octopus claim needs a genome, and genomes do not fossilize at all. The Kraken claim needs soft tissue, and colloid tissue almost never survives. The Silurian question needs sediment older than the ocean floor itself. Burckle needs a crater under 3,800 meters of water that nobody has imaged. The younger Dryas needs a synchronous layer across continents, and burrowing animals blur it. Now the ones that worked. The Mantle reservoir needed a single accidental inclusion inside one worthless Brazilian diamond. The Zanclean flood needed a buried channel found only because someone was drilling for oil. The origin of Earth's water needed spacecraft flown physically to comets because our own planet has overridden its own record. The pattern is consistent. The ocean is an archive that deletes itself on a cycle of roughly 180 million years. Continental rock keeps almost 4 billion. The seafloor keeps a 20th of that, and then feeds the rest into the mantle. Whatever happened on this planet before the Jurassic left no marine record at all. Not a suppressed one. None. No committee decided that. Plate tectonics did. So the theories in this video are not being buried, they are being starved of the evidence that would settle them either way. And the uncomfortable part is that starvation looks identical to refutation from the outside. A theory nobody can test and a theory nobody believes sit on exactly the same shelf. The people who published anyway paid for it in citations and in reputation. Some of them deserved that, some of them did not, and we will not know which for another 50 years. The ones who never published left nothing behind at all. Alistair Hardy waited 30 years and turned out to be partly right, and he is the only one we can count because he eventually spoke. The deep ocean does not keep secrets, it keeps almost nothing. And that is far worse.